The universe is an endless expanse. Humanity has always wondered if we are alone in this vast cosmos. Our quest to find life beyond Earth has led us to the nearby Alpha Centauri star system. Orbiting the red dwarf star Proxima Centauri is a planet that has sparked immense curiosity, Proxima B. Since its discovery in 2013, Proxima B has captivated both scientists and the general public. Proxima B is classified as an exoplanet. This means it orbits a star outside our solar system. What makes Proxima B particularly intriguing is its closeness to Earth. Located just over 4 light-years away, Proxima B is our nearest known exoplanetary neighbor. Its proximity, coupled with its position in the habitable zone of its star, has led to much speculation about the potential for life. Could Proxima B be a second Earth, brimming with life similar to our own? Or does it harbor life forms beyond our wildest imaginations? To truly grasp the nature of Proxima B, we need to delve into the characteristics of its star. Proxima Centauri is a red dwarf star, significantly smaller and cooler compared to our Sun. These stars are quite common in the Milky Way galaxy, but their dimness makes them nearly invisible to the naked eye. Proxima B orbits its star at a mere 7.5 million kilometers away. That's about 20 times closer than the distance between Earth and the Sun. This tight orbit means Proxima B completes a full revolution around its star in just 11.2 Earth days. Imagine celebrating New Year's every week. While this close orbit raises questions about the planet's potential for life, it's crucial to note that Proxima Centauri is much cooler than our Sun. Consequently, Proxima B receives a similar amount of energy to what Earth gets, despite its proximity. This positions Proxima B right within the habitable zone, or the Goldilocks zone, where conditions might allow liquid water to exist on its surface. While Proxima Centauri offers the tantalizing possibility of liquid water on its planet, it also poses a formidable challenge: stellar flares. These aren't just minor disturbances, they are massive energy eruptions that can dramatically impact any nearby planet. Red dwarf stars are notorious for their volatile nature, frequently unleashing intense radiation bursts. Despite being smaller and cooler than our Sun, they are far more unpredictable. Their flares can release enormous amounts of energy in an instant. These stellar flares can be hundreds of times more powerful than the strongest solar flares from our Sun. Picture the most intense solar flare ever recorded, then amplify that by 100. That's the magnitude of energy we're dealing with. Imagine being engulfed in a sudden, intense burst of energy. For any life forms, or even the planet's atmosphere, this could be devastating. The energy from these flares can strip away protective layers, exposing the surface to harmful radiation. This is the reality for Proxima B, which orbits its star at a close distance, putting it directly in the path of these powerful flares. These flares could strip away a planet's atmosphere, leaving its surface exposed to the harsh radiation of space. Without an atmosphere, the planet would be vulnerable to the full force of cosmic and stellar radiation. They could even boil away any existing oceans, making the planet completely uninhabitable. Water, the essential ingredient for life as we know it, could vanish in an instant. However, recent observations from the James Webb Space Telescope have provided a glimmer of hope. This advanced telescope has given us new insights into the behavior of Proxima Centauri and its flares. While Proxima Centauri does indeed unleash powerful flares, the telescope has revealed that these flares are often directed towards the star's poles, not its equator. This directional pattern is crucial for understanding the potential habitability of Proxima B. This means that Proxima B, orbiting in the star's equatorial plane, might be spared the full impact of these energetic outbursts. The planet could be in a relatively safer zone, shielded from the most intense flares. So, is Proxima Centauri a nurturing host or a destructive force? The reality is complex. The star exhibits both calm and violent behaviors, making it a double-edged sword for any potential life on its planets. The jury is still out, but the answer likely lies somewhere in between. Proxima Centauri's flares are a significant threat, but their directional nature offers a sliver of hope for the planets in its orbit. Life on Proxima B, if it exists, would have to be incredibly resilient to survive in such an environment. It would need to adapt to the constant threat of radiation and the potential loss of its atmosphere and water. But life, as we've learned from our own planet, finds a way. From the deepest oceans to the highest mountains, life on Earth thrives in the most extreme conditions. Perhaps, just perhaps, life on Proxima B could do the same, adapting and evolving to survive in the face of such formidable challenges. Tidally locked, one face to the Sun. Proxima B's close orbit around its star results in a fascinating phenomenon called tidal locking. This occurs when the gravitational forces between the planet and its star synchronize the planet's rotation with its orbit. Essentially, this means that one side of Proxima B always faces its star, similar to how the same side of the Moon always faces Earth. Consequently, one hemisphere is in constant daylight, while the other is in perpetual darkness. Imagine a world where one side is forever bathed in sunlight and the other is cloaked in eternal night. This stark contrast creates an environment unlike anything we experience on Earth. Tidal locking would dramatically affect Proxima B's climate. The side facing the star would endure extreme heat, while the dark side would be frigidly cold due to the absence of sunlight. The sunlit side could reach scorching temperatures, potentially hot enough to melt rock, while the dark side would be locked in a deep freeze, with temperatures plunging to hundreds of degrees below freezing. These extreme conditions might seem inhospitable for life as we know it. The harsh environment would challenge any form of life to adapt to the severe heat and cold. However, recent simulations suggest that Proxima B could still have a temperate zone, a twilight zone, where temperatures are just right for liquid water to exist. This zone would be a narrow band where the day and night sides meet. This twilight zone lies along the terminator, the line separating the planet's day and night sides. Here, temperatures could be moderate enough to support liquid water, which is essential for life as we know it. The existence of this twilight zone depends on the presence of an atmosphere. An atmosphere would be crucial in distributing heat around the planet, preventing extreme temperatures on either side. An atmosphere could circulate heat around the planet, moderating temperature extremes and potentially creating a more hospitable environment. This circulation would allow for a more even distribution of heat, making the twilight zone a potential haven for life. If Proxima B has an atmosphere capable of such heat distribution, it opens up the possibility for life to exist in this twilight zone. The unique conditions could foster the development of life forms adapted to the constant twilight, creating an ecosystem unlike any we have seen before. Future missions and observations will be crucial in determining the true nature of Proxima B's atmosphere and its potential to support life. As we continue to explore the cosmos, Proxima B remains one of the most intriguing candidates for finding extraterrestrial life. The twilight zone, where life might find a way. Picture a world in a state of perpetual twilight, where the sun lingers eternally on the horizon. Here, day and night merge into one, casting the sky in a mesmerizing blend of orange and red hues. This could be the scenario on Proxima B, provided it has the right kind of atmosphere. Such an atmosphere could protect the planet from harmful radiation while allowing the star's warmth and light to reach its surface. This twilight zone, illuminated by the gentle glow of a red dwarf star, might be a sanctuary for life. Proxima Centauri, the red dwarf star, emits a steady, soft light that could support a unique ecosystem. In this zone, temperatures would be just right, not too hot, not too cold. The balance of heat and light could create a stable environment, one where life could potentially flourish without the extreme conditions found on other planets. Liquid water, the essence of life as we know it, might exist on the surface. Water is crucial for all known life forms, and its presence would be a strong indicator of the potential for life. With water comes the possibility of oceans, lakes, and rivers, all potential cradles for the emergence and evolution of life. These bodies of water could host a variety of life forms, from simple microorganisms to complex multicellular organisms. Life in this twilight zone would be unlike anything we've ever seen. The unique conditions could give rise to alien life forms with extraordinary adaptations unlike any on Earth. If plants exist, they would have evolved to photosynthesize under the dim red light of Proxima Centauri. These plants might have pigments unlike any found on Earth, allowing them to efficiently capture the scarce light available. Animals might have developed unique adaptations to navigate a world of perpetual twilight. They could have enhanced senses, bioluminescence, or other extraordinary traits to help them survive and thrive in this dimly lit environment. The possibilities are both thrilling and daunting. Scientists are eager to explore these potential habitats, driven by the hope of discovering life beyond our planet. Proxima B's twilight zone could be a barren wasteland, or it could be teeming with life waiting to be discovered. The mystery of what lies on this distant world fuels our imagination and our quest for knowledge. Only further observations and perhaps one day, a mission to this intriguing world will reveal the truth. As our technology advances, the dream of exploring Proxima B becomes more tangible, bringing us closer to uncovering the secrets of this twilight zone.